as at then, I didn't really know anything to really do afterwards. So I just like, let me quickly take up this one. I heard it's the sexiest job in the 21st century, blah, 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 and the rest of it. So I just hopped on the boat and I just started learning and all. But afterwards, I've attended many boot camps, trainings, uh, worked with several bodies and all. So I've actually been attending a number of boot camps and all. So it has really helped me grow my skills and really give me the community feel of working with others and learning a lot from a lot of other people. So that's really helped me in my journey over time. Yeah, so that's pretty much how I got into the field. And currently, I'm working with e-health for everyone as a Python data scientist. Although in reality, the way it seems sometimes, it's just like you getting the job done. It doesn't look so direct as it is on paper, I would say. So like you might just have learned in on tutorials about just some machine learning stuff or some things. But in real life, you might be doing a lot of data engineering. That you have to work with database directly. Your data will not be in CSV to be cleaned. Your boss just wants to see results. So you just have to really be much more creative. And that's the leverage of actually knowing the language itself, knowing Python, because it won't be as neat or as nice as it should be on paper. So I always encourage everyone that wants to do data science is to always know the language behind the particular thing you're doing. If you're doing the machine learning, you know the maths also. So it really helps you when things go sideways. It might not be as direct as you expect it to be. So yeah, that's all about it. And is there any question anyone? So before we move into our class properly.
Not yet.
Hi guys, any question?
None for now.
Okay, none for now. Good, good. I think Kenneth wants to say something, but his network is poor. Hi Kenneth.
I'm sorry, my mic is actually turned off from this place. I don't know why you see it. My mic is muted.
Okay. So what can we do now? Can we just? I think we just move on. We just move on. So I'm going to share my screen right now. Can everyone see my screen?
No, it was showing before, but no longer.
Okay, I'll get it up now. Oh, can anyone see my screen now?
Yeah.
All right. So we're talking about naive Bayes. Naive Bayes. We're going to look at this content, the background, naive Bayes basics. I just saw a typo right now. Really sorry about that. Bayesian classification, naive Bayes, use basis of naive Bayes classification, and some conclusions. So the background. So let me just put it out. We're going to be kind of skipping through this part. The reason is just it's just explanation of the background and some story things that. But I want us to quickly get to the practical aspect where we are going to be running our codes, and we are going to switch to Colab. I can drop the link of that on the chat, so for the Colab, and then everybody can have it. So you can just run it online directly.
Yeah.
The notebook is already there.
You shared the link, but it's requesting access.
Whoa, I'm really sorry. I'm going to grant access now.
All
Immediately
right.
we're done with this one. Okay, so Bayes' theorem was named after a Reverend Thomas Bayes, who lived around 1702 to 61. He studied how to compute the distribution of probability parameters of the binomial distribution. So it wasn't introduced until after his death, and it was actually prepared and edited by his friend Victor Price in 1763, and all. So that's just the story behind that. And it's good to know he was a pastor or reverend. I was looking at possibilities of different things. So now, given the hypothesis, now this is just the general, how would I put it, general formula of Bayes' theorem. It's just the probability of occurrence of a parallel probability to an independent one. So I want you to look at this. In this place now, we have like the probability of H to D. This is like our target. So when we are like having a particular target, something we want to predict, we use the likelihood, which is this, multiplied by the probability of the previous occurrence of that particular one over the independent quantity. So we have an hypothesis, we have something, we have a probability of a particular occurrence, and then an independent probability relating to it. So comparing both, we can know the occurrence of the future of the other one. So now this when we say posterior probability, we're talking of what will happen afterwards, and the parallel one is what has happened before, and the likelihood is the possibility of it happening or not. So first of all, we're talking about probability. So we're talking about the occurrence of a particular event or not occurrence of it. So it might happen, it might not. And when it comes to classification, applying this classification just really tells us about us trying to separate different quantities based on the likelihood of similarities in a way. So yeah. So classification problem can be formalized using a posterior probability just like this. So probability of the same tuple. When we say tuple, yeah, it's not really the Python kind of tuple. Anyways, we're just trying to talk about the sequence of something from the start to the end, and yeah. So excuse me, I want to get something off my screen. Yeah, please. Yeah. So as we're saying, when we have that, it's just, for example, when we're talking about the outlook of the weather, whether it's sunny, windy, or rainy. So when we have like much more a windy weather, it's more likely to rain, I guess. So about when it's more sunny, when it's not less windy and kind of the moisture is different, we can predict and then classify this weather as okay, dry season or rainy season or that. So the idea is for us to assign a sample X of class C such that P, that the likelihood of C occurring on an independent probability X is maximal. So we're trying to maximize the probability and then know where it belongs to. So that's all about um, uh, Bayes theorem. As I said, it's just expressed in this simple expression formula right now, this equation. And then P of X, probability of X is constant for all classes. It's assumed to be constant actually. So in that case, and then P of C is the relative frequency of class C samples. So Bayes classification, now when we go to naive Bayes now try to now expand the Bayes theorem to a much more large data set, and it has proven to work really nice and well, even more than in some cases traditional classification models like KNN in some cases and some other use cases. We're going to see some of the cases that have been used for naive Bayes. So it assumes that all the inputs are conditionally independent. So if you have a large set, it kind of differentiates that dependability on themselves, and it makes it much more accurate. So when we have the map classification rule, map classification rule just to the right condition. Are we together, guys?
Yes.
Yes.
Okay. Please, if I'm going too fast or there's something not clear, kindly signify. All right, so uses of naive-Bayes classification, it's mainly used in test classification, spam filtering, hybrid recommender systems. Test classifications can be used in different things, maybe in news analysis and some other things. Spam filtering used in emails and some other spam detection. And when we are using a hybrid recommender system, that means maybe a mixture of a content-based and other types of recommender systems that we have. We use naive-Bayes classification for that. Recommender system applies to machine learning, data techniques, filtering unseen information, can predict a given resources, online application, simple emotion modeling. So why test classification? First of all, we are going to be doing test classification in our sample today, in the code, in the practical section. So most times, why do we do test classification? One of the basic reasons is that we want to learn um, about articles. You want to know, let's assume you read a lot of articles and you want to know the one that really fits into your interest, the one that fits into your kind of articles you've been reading in the past. So you can use naive-Bayes to classify that particular article and see if it's worth your time or not. You can classify web pages by topic. You can do information extraction, internet filters, and all with it. So you kind of bring it, what does is that it brings each document in training set and it becomes a record with frequency of each word in the vocabulary. So it has like a word bag, and then the word bag, you kind of vectorize those words and normal NLP things, not really deep into NLP anyways. And then we use it to train the model, and then it trains the classifier based on the training set and compute the parallel probability for each class and attribute. So, we have the posterior and the parallel. So the parallel is like our training set this time. So it computes those parallel probability based on your other articles, and then he now uses to evaluate the result on the test data, which now determine, this is what you should read next based on all what you have been doing in the past. And that's the probability of how it relates to your parallel data classes and attributes. So basically, naive Bayes is easy to implement and often works well. It's a good first thing to try when you're dealing with classification, and used as a punching bag for smarter algorithms. So we kind of just use it to check, then first before we now use some much more smarter algorithms to train. Yeah. So that's really all about that. Please, guys, any question?
We're good for now.
Okay. Tolu, everybody, we're good? Okay, that's fine. Okay. So I'm going to switch my screen now so that we'll go straight to. So I'm going to switch the screen. Yeah. So we're going to actually build a naive Bayes from scratch. So we're going to be writing. It's not really from scratch, so don't be scared. So can we see my screen now, everyone?
Yeah, we can see
Yes.
your lesson, but you've not gotten permission to do notes still.
Okay, so let me do that. So I have to share. Go to share. So it's a walkthrough. I would like everybody to follow. Um, like everybody to follow, and let me put it to edit, so everyone can just. I'll drop this link now on the chat. So the link is on the chat, everyone. The collab link. Has everyone seen it? Hello, guys.
Yeah, we have access already.
Okay, can anyone have access now? Does everybody have access now?
What's up now? The stuff is still loading.
Huh? Hi, guys.
Complete access. Yeah, I have complete access now. It's loaded.
Okay. Okay. Okay, so we're going to start with a few imports, and we'll just be importing the basic libraries, pandas, numpy, and collection. So this collection here,
Not
um,
yet.
Which one is stuck?
hello, I didn't get that.
I don't know where it's coming from.
Okay. Okay, so we are making a few imports. We are importing pandas, importing numpy, importing collections, and importing RE, regular expressions. So the collection there is just the default dictionary. It's like the normal dictionary. The only thing is that you can determine the default key. So in case you put any value that doesn't have a key, it gives it that default key. So that's just the difference between the traditional dictionary and the default dictionary. So the first thing we have to do is to run this. First of all, we run the first cell. So the first cell goes, and then we know that we have our imports in our workspace already. Are we together, guys?
Yes.
Okay, while that is running, let me explain this preprocessed string. And so, okay, that's fully run now. And then, so we have this function here. I try to put a dot string here that explains it. So example string to be preprocessed. What the function does? The processor preprocess the string argument string arg such that everything apart from the letters is excluded. Multiple spaces are replaced by a single space. String arg is converted to lowercase. So example, when we have something like this, menu is absolutely perfect. Love it. It's just, you can see what it does. It lowers everything and then remove the space and ignores the punctuation in this case. And then that is the processed string. Are we together, guys?
Yeah. Yeah.
Okay. So this is just writing the for the processed string now. We have a clean string. We use our regular expression sub. So if you put your cursor on it, you can read more about some of these functions. You can see this returns a string obtained by replacing the leftmost non-overlapping occurrences of a pattern in string by replacement REPL. REPL can either be a string or a callable. If a string, backlash escapes in it are processed. If it's a callable, it's part of match object and return a replacement string to be used. So sometimes those words come with backlashes. If you come with backlashes, normally it has another meaning if you run it through your normal string. Let's say backlash n, it's going to think it's a new line, and so that ignores it. That helps us take up those and then take up the space also. So the clean string is also now it removes the multiple space and then it returns finally the clean string. So this is what lowers it, converts the clean string to lowercase. That's why we have it as a lowercase. And then divides the other one, and then with this removes the empty spaces. The space is replaced by a single space. So that means when we have multiple space, it just replaces by one space. So and this function just returns that clean string. So all this is done step by step. Sometimes you might wonder if you try and put it up together, it might not be easy to understand. So it's better to just first of all remove, take all the alphabet, and then remove multiple space, and then turn it to lower. So this is just the simple dot lower method in Python string. Yeah. So do we all get that?
Yeah.
Okay, that's fine. So the next thing is we want to load the the data set you'll be using. The data set we are using is from sklearn. Sklearn is I think I wrote somewhere of that like the holy grail of machine learning in Python right now. It has the largest model set and all a very huge data set also. So we're taking a particular data set from there, which is fetch 20 new groups. We'll load the data set. So loading it, first of all, we're taking it from sklearn.dataset import this particular dataset, which is fetch 20 news group. It's a news dataset. And then it has categories. These categories, we want to put them into the categories of alt.our, atheism, sub.religion, sub-Christian, com.graphic, side.medicine. So after we load this dataset, it takes this category list we have here is what is going to the train. It's going to take it as a subset of that. So the fetch 20 news group has a subset train, and then the categories that we are looking at is just these ones we have highlighted: 1, 2, 3, 4. So you can see more about that about the data set here. Okay, you can see that here. If so, you can go into that's the documentation of scikit-learn itself, and then you can see more about dataset and extracting it, tokenizing, and more things with that. But we don't really have much to do with that, so we're going back to where we are right now. Are we together, guys?
Yeah, yes, sir.
Okay, so so yeah, somebody is already remotely having access to this. That's why he's writing that the file was uploaded remotely somewhere else. So I think one of us just need to have access to it first, or every other person can just do this. You can easily download. You can save a copy of it. If you save a copy of it, then you can play with your own without disturbing mine right now. Hello, guys.
I'm here.
Okay. Solo? Oh, I think you can't hear me. Okay, guys. Um, so if you run that, we are going to be downloading the OSKLN dataset, and then when you finish downloading, it tells us the length of the train set and the train labels as the output here. So now we want to put that into a data frame. So we'll have it in the data frame. To put in the data frame using pandas, the pandas we imported earlier on, dot data frame, the data frame and the data we are looking at, we kind of stack it. We are using column stack and using our NumPy to do column stack, and then the train data plus the train labels. So the data and the labels, and then the columns. We are defining two major columns here: training examples and training labels. And we just want to see the head in this case. So we can decide to see the tail, or we can specify the number of tail we want to see. If you put tail, we can say we want to see the last 10 for that in that case. So what this does, the column stack does for us mainly is just for us to kind of organize it and stack it on, because the data set here is not in table form, is not in data frame. So this helps us stack it up, and then these are the two stacking side by side, and these are us just naming the columns. Uh, this just us trying to see the last 10 data sets. Running this, you see the tail, and you can specify the number you want to see here, but the default is 5 anyways. So yeah. So now let's begin by processing the training data set. Training data set includes test cleaning and creating the BOW representation of our training set. We need the same test data set as well. So now I want us to look at something quickly. These labels helps us know just for identification of this particular example, the training data set. So the matching of them together is important. That's why we're using this tag. And since the default is a list, and it's list are serialized set of inputs, so they carry a position. We can easily do that with it. In some cases, you might really not have to use tag that way, but it just allows it to be much more done in a much better way, I guess. So now we are going to now use that function we created earlier on. Remember, we created a particular preprocessed string function ahead of us, and then you can see our dot string appearing here. So we put in our train string um, for train string in train data set. So this list comprehension uses our preprocessed string function on each of the train string for all the train string in train data. So you just take each element in the train data set and pass them to this function, and then we have our train data from there. Are we clear, guys?
Yes, I'm following you.
Okay. So you run that already also, and then so this is about now. After we do that, let's see how it's going to look like, because the main thing we are cleaning is this test. We don't need to clean the labels. The labels are just memorized already. As I said, they kind of help us identify the training examples. So this is how it's going to look like after we clean it. You can see how this looks like after we clean it. Uh, so now we can also specify. We can decide to see 10. Let's just see 10. Let's not assume by just the first 5. Let's see the first 10. Okay, the first 10 looks clean. We don't have the backlashes. We don't have excess space. And we don't have some other things we don't need in the data set anymore. So creating the bag of word representation in our training data set, need the same data set as well. So use the same data set as well. And then so here now we're going to be using another feature from sklearn. So sklearn.feature extraction.test import count vectorizer. And the count vectorizer there just helps us vectorizes our pack of words. So now remember something about when we're talking about the similarities of words themselves. So there's something they use in analyzing documents, and that's one of the basics even in, if I don't know if you've done it in algorithm before, or if you have ever taken a full course on algorithm, you've heard the concept of document distance, where there you take a particular set of words and then you look through different pages and see how they are similar. So it actually uses a mathematical distance vector stuff that just takes all the whole word and then count the occurrences, divide it by the total number, and then you get a particular set of vectorized words. So this in sklearn helps us achieve those complex things. You don't have to worry about that. So when you import this, it's waiting for test. You import count vectorizer, and the count vectorizer is what we have the object, the method here. We've taken it as count vect. So we now use that count vect to fit transform our train data. So we can now print that out. So and the shape. So here we just want to know the shape of the train data. Are we together, guys? Did anybody understand what I mean?
Yeah.
Okay, okay. So what is what the converter it takes in the test.
Sorry, I didn't get that.
Okay, okay. So let me go back on it. So now this is where I kind of explain the count vectorizer what it does. It takes a test corpus, builds its term document matrix, that is bag of words, and return it. Every word is assigned a fixed unique integer ID and value of each cell of the matrix representing the word count. So for example, this X string count ij, where I refers to the document, to a document which is a case for each document to provide a training example, and j refers to the index of the word w respective document. Now, let's assume you are searching for, let's put it like this, you're searching for, okay, this is not to scare anyone. Let's say you're searching for occurrences of coronavirus in Nigeria, and then what Google will just do is just take that word and then look at all the several pages it has in its index and check for coronavirus in Nigeria. It's going to look through several pages and then kind of check out the similarity between the document distance between what you want and what they have. So the most relevant one, what it's going to do is it's going to count how many times coronavirus in Nigeria exists on those different pages. And then, although it's more complex than that now, but that was the basic search engine stuff. Then it's going to now divide it by the total number of words in the article. So it kind of have a figure. So that I and J tells us the index and that particular word, assign it to the index of it. So that document, let's say document A, how many times that word occurred there is 5. And then what's the size of document A itself? So it's going to check, give it a value. So, and then the higher or the lower the value, and then it's going to compare it then to themselves, and the highest one has more similarity, like least document distance from what you are looking for. Do you get that?
Yes, I did. Thank you.
Okay, okay, okay. So thank you. Now we're going straight up down, so we can now print. So we're trying to print. Yeah, we're just printing. You know, our S train count is a list. So we are saying we're just printing the index 0 to 12,000. This 12,048, and it's giving us 1. So this is just to check our X train count is actually doing the right thing or contains the right information. So this is just the position 0, that's column, row and column for this particular one. Then that's because the shape, if we go ahead up, we before we printed the shape of this and we saw that, okay, it's 22,500 and 257 by 31,159. So if we print this guy also, like the OSS string count, we will see more details of the figures of that. So we have the I and the J, and then we have our label still assigned with it. So are we good, guys? Hello, guys.
Yes.
Okay. Okay, so that's it. Let's move to training. Let's train. So we're going to import naive base. So now take naive base and then from sklearn still. So use sklearn and then we there's a particular one we are importing there, the multinomial MB. So we have different kind of naive base. So you can look through the sklearn library, you see different concept of it, and there are just different variations based on the uh, the the idea behind it and the assumptions. Some assume independent, totally independent probability. Some may be dependent, and they have different use cases. But this one we are going to be using is multinomial. Multinomial, so it is can take multiple probabilities in this case because we are dealing with different documents here. So it's not just one or few. So that's why we're using this particular one. So this just instantiates the naive-based object, and we call it CLF. So and then we fit our train count because that's our preprocessed and the vectorized form, and then we now put it also, we train it with respect to our train label. So if we run that and see when it's completed, it's going to output training completed. That's so fast, right? So guys, we can now go to testing, and so testing here, we're just going to pick more. In this case, you can see that we on the usual thing you might have been doing is supposed to divide your training set into train and test, and this, but we aren't doing that here. So because the data set is actually large enough, we can pick other parts from the categories or another thing. It's the same category, but in that same data set, they already have a subset of train and test. So that's why you can see here, we just pick subset test for inside the same from sklearn. So we don't have to start dividing into train and test. And then we call the test data, and we will preprocess it also, because if we don't preprocess it, it won't be in the same format as our train, and we'll have issues, definitely. So running that, is going to output for us the number of tests, text labels, and text examples, and yeah. So the same count vect object that was instantiated for training dataset will be used for test dataset. But remember, we're not calling the fit transform, since we want to transform the test data into test term document matrix, whereas fit transform fit learns the vocabulary dictionary first and then returns a term document matrix. So we are supposed to learn the vocabulary on training data sets only. So we are not going to do that on our test data set. The vocabulary learning and all was just for us to vectorize our words and then check it back with the dictionary. So we can see now in this place, our S test, we transform it, and then we can now see the shape of the transformed data. Yeah. So now we can now use it to predict, because remember, there's something we just didn't do, only just one thing we did that we did in the train, which was this guy. We didn't do this. So let me go up 1 minute. So we didn't bother fit it into this count vectorizer because we didn't need to. We're not learning vocabulary here in this case. But this the whole library there helps us learn the vocabulary, because when it comes to word, as we know, language, which is English in this case, although this can be applied to any language, we have different words that mean different things in different contexts. So putting them into context and then looking at how it's the meaning and removing some words that needs to be tokenized or taken to their base form. That does it for us easily. Yeah. So right now, from here now, I think we stopped right here with training. Our training stuff is done. Hello guys.
No, I can hear you.
Okay. I was wondering, because everything looks well. Okay, so from here now, we can train this. So we have our test from the same data set, and we've also done a count vector transform for it, but we didn't fit it. So we can now go ahead to predict. So we can check for our text accuracy. So text accuracy is just simply us finding the sum of the predicted that is equal to the true, and then float of the length of the predicted. So we are looking for those ones that are equal with what we predicted over total length of the predicted. So that just give us a simple idea of our test accuracy. So we can say our accuracy is about 93%, which is not bad in this case. So can everybody follow? Have everybody followed me up to this point? Is there any question before we go to the other aspect of trying to do this thing in just 3 lines of code, I guess?
Hello, good afternoon.
Good afternoon.
Yes, I am kind of lost, like very, very lost. But I guess
Wow.
I will just have to go back and look at your codes and see. I don't want to draw the class back on this point. I don't think you understand a single thing.
Wow. Were you with us since beginning or you just joined?
I've been here since the beginning. This is Kenneth.
Then I have to go back. Any other person have the same issue? Hello, guys. Any other person?
Yeah, hello. I also have some parts that I didn't get at all. So
Okay, please identify that. Which part, please? Okay, I can't hear you again. All right, you know what,
what did you
guys?
say?
I said which part? Which part did you have issues with?
Since you're starting from the beginning, I think it's fine. I'll just thank
All right, guys. I don't know.
you.
Was I too fast?
You weren't too fast, but it's just something that is new to me. I don't know about every other person. So
Okay. So the thing is, as I'm explaining each cell, let me know if you have questions. Before I go to the next cell, tell me to go back,
uh,
guys. Is that okay?
all right.
All
Thank
right.
you.
Yeah, I guess everybody understands this first cell, what it does. It just helps us import our libraries, the pandas, the numpy, the
Yeah, we do.
collection, and the regular expression. So yeah, this is a preprocessed string function we created. It's not inbuilt, and then what it has is the preprocessed string, and this is what it does. So this is like a dot string for what it does. It takes the parameter. The parameter it takes is we call it string arg. You can call it any other thing you like. Call it string arg, and the example string that is to be preprocessed is taken into the string arg, and then uh, so everything apart from the letters is excluded. That's what this preprocess does, and it achieves that by using the regular expression. So we kind of broke it down into three. First, it takes all the alphabet. So anything that starts with when you're doing regular expressions, this I don't know what to call this particular punctuation, like raised to power, then it just tells you anything that starts with A to Z. So it takes in all the letters of the alphabet, right? And then any of those letters of the alphabet, A to Z, including space or plus. That means it might occur more than one. So it takes that into it looks through everything, and then into of that string arg, and it ignores the case. So ignore the case simply means that it doesn't care about whether it's uppercase or lowercase. So if you don't put ignore case, then now you'll be having issues with upper cases. And then after that, remove excess spaces. It replaces it by this, and then in the same clean string, and then it lowers it at the end. So and then returns the clean string. So do you understand this, sir?
Yes.
Yes,
Okay, yeah. You understand everybody?
very well.
Yes.
Okay.
We do.
Now, and what happened next was that we used the data set from sklearn. So we imported the already the imported data set in sklearn. So we called it. It's called Fetch 20 News Group. So it's a news group there, and it has categories. So we just take the categories we need. These four categories. So the four categories is what we determine here, and then the subset we are taking is this train. So that's why we didn't need to do the splits. So we didn't have to bother about that. You understand, everybody? Hi guys, are we together?
Very much so.
Okay, okay. So and this it just takes the length of the training date, and it shows it just for us to know that what we did was right, and then Colab kind of tells us when we're downloading it and Dataset and tells us that it's 14 MB, whatever that is printing out all those with it. So now we put the data set we have is actually like in strings, and it's just more of a list of those strings, a list of strings. So we put it into a pandas data frame. We just like make it, put it in form of a table, and then in our pandas data frame, the data what we do is just we use a column stack. So the column stack puts aside side by side the train data set and the train label, and then put the column name of that. So from that column name, we find the tail of it. So and then the tail is just giving us the last 10 values there. So are we together, guys? Do you understand up to this level?
Yes, we do.
Okay, that's cool.
Yes, we
Yeah.
do.
Okay. So what happens here now in this place? I guess it might be one of where you think came a bit it looks a bit complex, and it's actually just not. What we need to do here is list comprehension. So if you're familiar with list comprehension, maybe I should just check itself. Let me do something here. If we a simple list comprehension is just a simplified way of doing for loop, I would say. So let's say I want to create a list.
Sorry, we can't hear you. Your voice has gone really low.
Okay, can you hear me, guys? Is
Yeah,
it
no, we
better now?
can't.
Okay, I think it's my mic. All right. So what I was saying was that a list comprehension that is used here is just a list comprehension. The simplified for loop. We would have used a for loop here, but instead of doing that, the list comprehension is faster. List comprehension is also simpler to use. So we could have written this whole thing as saying for let's say for train in this case, what's the name of what we're looking for? So we call it string, Abby. So just like for each. So we call it for this in train data. For this in train data, we are selling it to pre-process string of the train string that we already have, and then we're asking it to add it to this train data, which is also a list. So we can just do something like this and say we are saying train data dot append this whole thing. So now, but obviously we need to create our train data somewhere. So how this is what this one line does for us. This one line does for us. Are we together, guys?
Yes.
Is it clear, guys?
Yes, yes.
Okay. So okay. So that's exactly what this does for us. And then so this you can see I will actually encourage you to use list comparison in most things you do. It's just really helpful. So it can really make your work look more professional. So it's just a step higher than for loops and all when it comes to list and all. So from that now, this is how we got up to this point. and then we created a data frame here. A data frame, we took the data again, and now we put the already processed the already processed the data train data still beside our labels, and then do our stacking, and then we look at the head, at the first 10 values. So the next thing was the bag of words. Created the bag of words again. We created bag of words of our training sets, and then we went back to sklearn. So sklearn had this count vectorizer. So I explained what count vectorizer does here. It takes in the test corpus, use its term the document matrix. So first of all, when we say document matrix, as I tried to explain the other time, so document matrix is it's just a tabularized form of words. So let's say in a statement like I am going home. I am going home today and I want to see my mother. And I want to take like a matrix of that particular set of words I said. Hi. I'll count how many times I is in my old document. I'll put I and I'll put my high is maybe 5. I am this number, that number, and this. But instead of putting directly just the number, what they do is they put the vectorized form of that number, and that is just counting the occurrence of that number over the number of everything. That's like normalizing it. So, and then they put each of those values, each of those index aside of it. So it's a bit more complex when it comes to count vectorizer, but that's the basics of what happens there. Are we clear about that, guys?
Yes.
Yes.
Okay, so we have the X train count, and then it uses that count vectorizer and it fits into it. So it's also like a model. So we have to first fit our train data set into it. So fitting it into it now, we can have a new set of our train data count. So it doesn't affect our that doesn't affect our label at all. So that's why our label is still intact. So that's why you can see where we printed it out. We see this is our document, and this is still the label side by side. Are you together, guys?
Yes.
Okay. So then we can now train. So training now we are still going back to sklearn. That's our naive base, and then we went to import our multinomial naive base, and then so we initialize the naive base object. So we could actually just write multinomial with a bracket and then put it in front of fit, but this is just a better way of doing it, and it looks standard. So that's how we did that. And you can always call it anything you want anyway. So let's say we want to call it 210 or whatever. It's not a must to this. So can you say STU and STU here? But yeah. Training for us. Our training when it's completed. Are we together, guys?
Yes.
Okay. So our training when it's completed, we can go straight to the next thing downward, and then we got our test again from that same news group. So our test we got it from the news group, and then yeah. So that's what we did, and then we have to take our test also through the same process. So we have to first process it, and after processing it, transform it. So, but we don't need to fit it because we if we fit it, that's like we are defeating the purpose of test. Test is just for us to check. So we didn't to fit that. So that's why we didn't fit it. And then we went to predict down here. And so our accuracy was 93%. So do we get it now? Does it make sense now?
Much better than before.
Okay. Are there still gray areas? Can you identify any gray area before we move on?
Not really. I think this time it's better. So it's left to me now to go see iPad and brush up on it.
Okay. So we have
No
here.
gray area from here too.
Oh, that's cool. That's cool. Thanks, guys. So now, this is just like a more shorter way of running the whole thing. You can see everything we're running from beginning, aside from our pre-process stuff. Aside from the pre-process part, you could actually write it in few lines of code, and it's still sklearn. So sklearn now we call pipeline. Pipeline is actually very, very important sometimes, especially when you're writing your machine learning models, especially in production. Most times you need pipelines. Pipelines just apart from simplifying it, it ensures that you don't miss out on anything when it comes to the process. And by the time you are putting your codes in production, it won't be in Jupyter Notebook by then, and so it's much more better to use pipelines. Yeah, so we simply build a pipeline object by specifying the pipeline action, and once the pipeline object is used in training purpose, it will automatically perform the pipeline steps in the specified order. In our case, as we have first, we want to build a count vectorizer for both of the bag of words and then fit training naive Bayes model. So in exactly the same manner, we specify this action in our pipeline. So pipeline will just follow the steps, but this time we can easily do as if we are appending it. So what we do is just, okay, look at this, we have a fit, and then we took a pipeline, count vector, count vectorizer. It performs all this sequentially on the train test data. So it takes this first, this is like the first step, and then when it's done with that, it then uses this on that. So now I want to imagine like a normal pipeline, So you are joining a pipe to another pipe to get where we are getting to. So this is like our first pipe, and then this is like our second pipe. Do you understand that, guys? Hello, guys. Hello.
Hello.
Did you get that, please?
Okay, now.
Huh?
Yes. I didn't get this last part.
Okay, good. So what I was just saying is that I
I
was talking
did
about
not get
pipelines,
this last
and
part.
yeah, I was talking about the pipeline, and the pipeline I'm talking about here is like the steps, the same step we have done earlier on. So we are just going to specify in the pipeline. So this pipeline is an object that takes like a list of the steps you are taking. So we call a particular we're telling the pipeline that, okay, it's going to call this guy count vector count vectorizer, and so it takes the object from, we already imported all these. That's why we need to import it again. So this particular function is taking it as this guy, is calling it this, and then this particular function here is calling it this, is this one. So the first thing we did was we used count vectorizer on our trained data, and then we now applied our model on it. So that's the same sequence of action we are taking. So we are going to put in the pipeline, then we fit it into the model, and then it goes that way. Do we get, guys?
Okay.
Now I do.
Okay. So you can look into pipelines a bit more. You can see this is the dot string is actually really nice also. So if you put your over your cursor on it, I don't know, should give you some more a bit detail. Why is that not doing that? I think my network is poor. So to give you detail of the pipeline, and you can read more about it in the documentation. So if you do the same test prediction and test on it, we will still have the same accuracy. Is it clear, guys?
Yeah, it is to an extent.
To an extent. Okay, so the thing
I
is
don't. I
now
can't
that
completely. I can't completely grab everything now, but it's clear what you did. Later on, if I go through it.
okay. So I would just say two things, like it's not as difficult as you think, first of all, and then because of the fact of sklearn, we didn't have to go to the hassle of trying to write that formula of probability in the math and all. Get out to import and use. I would have loved us to do that part, but that would have been more stressful right now for us. So it's always good to learn it like this. But if we didn't do the theory part, the model will just be like a black box, which you won't understand why if it happens that it misbehaves, you won't understand why it does and why it does not do what it should do. So I guess that's all for now. And yeah, so pretty much I would love to have any further question or any other observation or feedback generally right now. Hello guys.
Yeah.
Yeah, I was asking for feedback, observation, question, backlash, anything.
Okay, I have a question.
All right, please.
So, is this naive base only restricted to quote and unquote unstructured data, the ones that are not tabulated?
Okay. Is that all? You have any other question?
Yeah, that's all.
Okay, okay. Okay, so the data we're working with is not really unstructured. If you notice, we have to do pre-processing. The only use case here that is peculiar here is because it's test classification, and that's one of the like major use of naive Bayes actually for test classification, as we saw in the uses and all. Um, it's not really unstructured. If it's really unstructured, we wouldn't have done our processing and then try to vectorize those words and all. Although that's still normal test processing stuffs generally. So interestingly, by the time you start something like natural language processing, these same few steps that we did earlier on will come in very useful, where you talk about vectorizing words, bag of words, and see something like tokenization, dissemination, and some other language-specific processing stuffs you have to do. So particularly for test. So anytime it comes to test, we still do pre-processing. So it's not really unstructured. Uh, every data needs to be cleaned and pre-processed generally. Yeah.
Okay.
Any other question, please, guys?
I can't think of any question now.
Okay. Okay. So now I would like us to do something. I would like us to go through this particular data set, and then we are going to choose other class categories that we didn't talk about. So we talk about categories. You're going to go to sklearn and the documentation, and then fetch this 20 news group, and then check other categories that we didn't mention, and you check the train and test of that, and then do the same thing on it. Does that make sense, guys?
Yeah.
All right. So when should be the deadline for that?
Maybe you should set the deadline. Then we'll try to work on it.
Okay. If you ask me to set the deadline, I'll be very brutal.
Please don't be.
Eh.
Please don't be brutal. Oh.
All right. Okay. I think a week is enough. Then it's more than enough. So we can look at next week Friday.
That is not brutal. That's fine.
So I would like to see the notebook. You're going to send me a mail.
Sorry. Objection.
Okay.
Somebody like me have a very, very tight schedule. A week might be a little bit too small for me. Yes. Next week, Friday may not work for me.
So when will work for you yourself? When you choose a time now?
Maybe anything after that, because I have a very, very tight schedule.
So Saturday is after that also.
Okay, the week after, anything from the week after, I think I should be able to.
Okay,
I should
so you're saying 2 weeks
dedicate
right
next
now.
weekend to it. I should dedicate next 2 week. I should dedicate next weekend for it. So anything from Monday, the following week after, I should be ready.
Okay, so we'll make it next upper week Friday. That's 2 weeks from now.
Okay, that's sweet for me. Thank you very much.
So what? Yeah, so that means you guys send me a mail and then you attach the Jupyter IPYMB file, that's the Jupyter notebook file, to the mail of your solution. Is that fine, guys?
Or we could just share the link if we use Colab.
Okay, if you use Colab, you can just share the link also, yeah. But if you don't use Colab, you can attach it to the mail.
Okay. So
Aside from what?
aside from we using the other, how many data sets do you ask us to bring in?
Okay, I want you just use 5 other categories that were not used in this example we used from that same data set. We use 5 categories here, right? I'm trying to scroll them up. Yeah, so any other 5 categories that is not in this 1, 2, 1, 2, 3, 4. We use 4 here. So use another 5 categories or 4 categories. Just use 4 categories. So the data set won't be too much.
Okay.
Sounds good.
Okay, guys.
Hello.
One more question. Or is there 2 questions? Please go ahead.
Can we still reach out to you if we have any challenge
Okay, yeah, definitely.
while doing? Where can we reach you?
Okay, so I'm dropping my mail now. My mail on the chat. And also you can reach out to me on LinkedIn. You can reach out. I can drop also my WhatsApp number if that is allowed. That allows to 10. I can't get a response.
Oh, are you asking us or are you asking
I'm
students?
asking though. I'm asking students. I don't want to breach terms and conditions.
I don't think that's a problem. Upper is not here yet.
Okay.
If it's fine by you, I think it's no problem.
But yeah, no problem. Just that. Anyways, please kindly be patient if I don't reply early enough.
I understand.
Okay, so I dropped my mail now and dropping my WhatsApp number. So that's it for now then. So apart from that, is there any of us that is looking at going into
Stop nonsense.
machine learning or trying to explore in full stack machine learning stuff before or right now?
Yeah.
Yes.
Okay, that's
Couple of us actually.
good. Okay, so SKLN is really a big deal. SKLN is really a big deal, and you might really need to find time to kind of go through the documentation. So this will give you like a first look into the SKLN documentation. So the thing about SKLN that is that SKLN can kind of make you lazy. Although as an engineer, you have to build models in real life. So you might not have a model that is existing already. So you should look at how it's written. So the SQLN provides you the process of how it's written, so you can even see for yourself and understand the models. Yeah. Okay. So I guess that's it for now. I might soon have to go. I have a meeting in a few minutes, and
All right, no problem.
I'd like to
Just a quick
appreciate
one.
everyone for their time, and
Sure.
it was really an honor being here.
All right, no problem.
Okay, okay, guys, please kindly reach out to me on any issues, and let's respect our deadline. Thank you.
Thank you so much.
Thank you,
Thank you. It was good
everybody.
to have
So,
you.
yeah, bye Tolu, bye AY, bye Kenneth, bye Otse, Ken, Ayola, Simeon, Ayolola. Yeah. So bye
Thank you very
everyone.
much. All right, bye.